this, and this is 5-2, the alpha lesson. And you got a lot of learning objectives. And now you're going to see that moving forward, you'll see more of these. You need to take a moment and read, definitely skim it. So you see Riemann sums there, which we introduced to you yesterday, here, approximate a definite integral. So the point is, approximation is a learning objective here. Like, well, you know, I just want the exact answer, some of you have to get it. You're going to have to be able to do approximations. So here's a question, which we could answer from the end. We could answer now. Because this is more of a language arts question. It's problem 46 at the end of the section. Which of the following quantities would not be represented by the definite integral? Now, definite integral, right? This is a Roman S. It means the sum of what? The sum of height times width from 0 to 8. When you read these choices, which one doesn't make sense as an answer to the question? Here we go. Yeah, A doesn't make sense, why not? Well, you're right, it's your big guess. That's not good. Hope we don't count that in that. Ben. Units don't match. Because the question says the train's going at 70 miles per hour. Okay, well, that's this. That's the 70 for 8 minutes. That's miles per hour for 8 minutes. So how could you change A to make it work? One word. Lucas. Hours. Correct. Change this last word to hours, and then all these would represent that question. Okay? So we're going to go to example 2, and here's what's going on in this section. Actually, I want to do one thing before example 2. But here's what we're doing. We're just dealing with, we're not using any calculus. We're doing areas that you can do with geometry and just go into the calculus notation. So the notation is here. We are on page. This is what the question looked like. We're on page 277. So what have you got? You've got a lower limit and an upper limit. That was the same thing we did. Like we did average value talks. Remember? I didn't like calling them A and B because C was in between A and B. So these are inputs from A to B. This integral sign is a Roman S. It means the sum. The sum of what? Well, f of x means the height. That's another way of writing y. dx is your width. It's your change horizontally. So what are you doing? You're saying, if you think back to what we did with the Riemann sums, 5-1, you've got all these rectangles. And you're adding up the rectangles. From A to the left to B to the right, they're this high in that line. If you add up all the area of all those rectangles, you're going to get the area under the curve. And then what's this really saying? The dx is the width. But remember, the change in x is going to 0 from limit notation. So these rectangles are really, really thin. So you've got a lot of them. So as the dx goes to 0, then what we did in the 5-1 lesson, these would get thinner and thinner and thinner, and you'd have more and more and more of them, so that it would go to the exact area of the curve. Now think about what that means. See, in 5-1, what happened? We did LRAN, RRAN, and MRAN. And you saw if you did delta x was 1, we got an underestimate, overestimate, and something in between. Then they made delta x smaller. They made it 5/10. And we have software to share with you. People have it. People have areas by Josiah if they were in AD this year. And last year what we did is we did 5-1, one day with technology one day without. So we'll come back to that when we can give you, we can share those area programs with you. But the point of this is, if you think about those rectangles, as the width gets smaller and smaller and smaller, you've got more and more rectangles. And if the limit of the width is going to 0, then the area of the rectangles will add up to the exact area under the curve, which is what we're trying to find. So example 2, ready? We have this. We want the area under this semicircle, where the radius is 2. Well, we know how to do that. The formula for area of the circle is pi r squared. So in this case, r is 2. You would have pi times 2 squared. You would have 4 pi. But you don't have the entire circle. You only have the top half of the circle. So you would have 1/2 of that. And that shaded area would be 2 pi. Make sense to you? So we're going to work backwards from the answer. We know the shaded area is 2 pi from geometry. So now we're just going to write a calculus question that matches the answer. And then later in the chapter, we will do the actual calculus if we didn't know the area of geometry. What are we saying here? We're saying A, the left bound, the left limit is -2. B is 2. So you go from -2 to 2. And you're adding up, as for sum, adding up all these rectangles that are here. All these little rectangles, they're how tall? They're this tall. Where does this come from? Well, it's a circle. X squared plus y squared. How does this work? X squared plus y squared equals r squared. So what's the height? Y squared equals 4 take away x squared. We take the square of both sides and we get y equals 2 branches. Except we're not dealing with the negative branch because that's below the x-axis. So we just have that. What's that? That's the height. That's the height of those rectangles. And how wide are they? dx. So we work backwards from the answer. The answer is 2 pi, and the question is that. Has nothing, right? You didn't use calculus to do this. You just used the calculus way of writing the question. So that's your model. You're going to go do problem 15, please. All right, so for 15, it's the same question, except what? The radius is 3. But the radius is 3, the area of the whole circle would be 9 pi. The way of half of it, 9 pi to 2. This is the way the question is written. What does it mean? It means starting at -3 and ending at 3. Out of all the rectangles, they were this tall and that wide. You say what? Yeah, you have two groups. You have a full circle. You want the area of that, you need to use the geometry of that, right? And the graph we have to go over. But this is what's important. Like literally, you have to do minor off the step. This S, it's like this. It's like this signal. I think people know this. That's a Greek S. So, you know, that means sum. Same thing, except that's a Roman S. The sum of what? Of a rectangle that's that tall and that long. Add them up. Start here and there. In the textbook, on page 279, if the area is below the x-axis, it's negative. If the area is above the x-axis, it's positive. So like, think about this. Suppose you have the sine wave. So the sine wave from 0 to 2 pi, there would be 0. Because this is positive and that's negative, and they would add to 0. What is this? Let's go here. Oh, speaking of the sine wave, they're telling you this. This is given. It's true. And we'll show you how to do this. We're not there yet. But we're going to start with the area under the sine wave from 0 to pi equals 2. It's 2. That shaded area is the area. So question A says, or question 1, what would the area be starting at pi and ending at 2 pi? Then -2. Because question 1 is referring to this area. So I would say equals -2, and here's your job. You're going to finish this page. You have to justify it. So the way I would justify that is, this is the given area, in a sense, reflected over the x-axis, where y equals 0 is the way we're going to get. What did you do? You came up with a numerical value based on that which was given, and you had some way of justifying that your answer. Okay? So you're just going to go to the rest of this exploration, which is in your book on page 279 in the bottom corner. So, the answer to 2 is 0. Why? Why? Because you're going from 0 to 2 pi. So the area above the axis and the area below the axis would add to 0. Right? And the justification would be 2 plus a negative 2 is 0. Getting all low numbers. Oh, we got somebody in the room. Luke Kennedy, next one. Number 3? Correct. Number 3 would be 1. Why? Because you're only going from 0 to pi over 2. So what is that? That's a size change, ready, of 1/2 comma 1. The y stayed the same. We're going with half as far to the width. You get the hang of this? Six. Evan Gallagher. Popular choice there. Unmute, Evan. Oh, we got a chat from Evan already. He will do 9. Skipping right to the end. Now you have the cosine waves from 0 to pi. Let's see what Evan got. He got 0, it's correct. Does that make sense? Because number 9 is going to be 0, because the cosine wave would look like this, right? And you would have 1 plus a negative 1, the area above the axis and the area below the axis. Okay? So, if you're at home, happy Thanksgiving. You are dismissed to go to the exit ticket, and the children in the building will finish the rest. Okay? Well, we're not going to see them in the building. So, what else? Wait a minute.
Number 4 would be 2 plus 2 pi.
Yeah, number 4 is harder to see, okay? So number 4, what do you got? Here comes the sine wave. We know that area is 2. Yes? But what happened to it? It's really y take away 2 equals sine x. Does that make sense? So if it's y take away 2 equals sine x, then this graph got moved up 2. Well, that's the same thing as moving the axis down 2. And what did you do? You inserted this rectangle underneath the sine wave. So we know this part's 2, and this part is 2 tall and xy. So it would be, you only go to pi. So it would be 2 plus 2 pi. Because it is a slide of 0 right or left up 2. And you slid a rectangle underneath the area that you did. Right? That was hard. What about 5? What would 5 do? Oh, it would be, sorry, because you're going from 0 to pi. What's that? That would be a size change of magnitude 1, 2. Because this is really y divided by 2. And by doubling the y values, the height of the curve, you would double the area. What else? Ben?
6 would be 2.
6 is 2, why?
Because you just slide the graph left and right, doesn't
Yeah, look at what the inputs are. It doesn't go from 0 to pi. The inputs got slid to the right. So when you put the lower limit in there, you go from 0, upper limit, to pi. So we already did that.
8, 0.
8 is,
Is it not 0?
it is not 0.
What? Is 2?
Well, ready? Let's do 7 first. What do you notice about 7? I don't want to do that, it's got a mu in it. Doesn't matter. It's d mu. You're fine. That's the height and that's the width. So just think about the sine wave from negative pi to pi. That would be 0. Make sense? Because you're below the axis plus above the axis. And 8 would be 4. Ready? It's the sine of x over 2. You did a scale change of 2 to the x and 1 to the y. So if I graph that, and we make the window go from 0 to 2 pi. Is that what it was? Zero to 2 pi. So all the areas above the axis. So what did we do? We stretched that graph horizontally. Okay? So